We all do everything humanly possible to avoid accidents. But some are simply unavoidable.
The need to mass-produce cars more cheaply brought about the introduction of the monocoque or chassisless method of vehicle bodybuilding earlier this century. Today's motor car, often described as being of unitized or integral construction, has now been developed to meet very tough safety standards. At the same time, it must be able to attract purchasers in a marketplace that becomes more competitive day by day. Monocoque bodywork can be designed to meet stringent safety requirements. It can form a very strong passenger safety cell, and with energy-absorbing crumple zones, a high level of occupant protection during impact is possible. Detailed modifications to the body design, the way each panel is joined to its neighbor, for example, has also made the body suitable for extensive anti-corrosion treatment, another plus point for many buyers. Corrosion prevention is taken to the ultimate level with the use of galvanized steel. High-strength steels are now used by many makers, but only some use it to any great extent for body panels. Generally, weight is reduced to aid performance rather than greatly improving the strength of the body, and is noticeable in the use of thinner but stronger material. Present-day body design and high-quality manufacture can provide long life, with safety always assured. Equip this body with the many different active safety features available, and it seems impossible that accidents could ever happen. But they do. And it is the joint responsibility of the estimator and the panel beater to restore the shape and the safety of the bodywork. The painter protects it, and the mechanic reassembles the life-giving systems. All these personnel contribute to a successful and a cost-effective repair. But it is the panel beater who probably has the most critical job. When finished, the car must certainly look good, but the bodywork must also be rebuilt to factory standards. The safety cell, as safe as before, and with crumple zones that absorb impact energy as they were designed to do. Above all, the panel beater is responsible for ensuring that the steering and suspension are correctly positioned. This most basic but all-important safety system can only do its job if the components are in their correct place and at the proper angle. On many vehicles, there is little and sometimes no adjustment to overcome built-in errors. All these obligations demand from the panel beater an awareness of present-day constructional techniques and knowledge of the materials that may be used during production. Galvanized coatings and high-strength steels positively prohibit the use of heat to relieve stress. Beating the stressed areas is the most effective method. Pulling will also demand particular care where high-strength steel is involved. The damage must be eased out with frequent stress relief by beating. Often, thinner sections of this material are used, which may give rise to tearing unless the load can be spread or a multiple pull employed. Even so, careful watching and frequent inspection are essential if problems are to be avoided. Where a vehicle has a high level of anti-corrosion treatment, or it is made of galvanized steel, there should be little or no corrosion, and the damage and pulling work will be virtually the same as for a new car. Because a great deal of effort may be needed to pull out crumpled bodywork, only good quality equipment, designed and made for the purpose, should be used. Any component that is suspect should be replaced. And always, always use a safety strap on the pulling attachment and chain. This program was made using several types of equipment from Audi Volkswagen's approved supplier, Celette. They include bench-mounted measuring equipment, a floor-anchored pulling and repair system, and a full bench-based pulling and bracket rebuilding system. Loading a vehicle onto equipment is often undertaken in a hazardous manner. Apart from personal danger, the equipment or the car may sustain damage through the use of inadequate lifting devices. In general, trolley jack should be used only as a last resort, and even then only on components due for renewal. As a rule, only lift at the car maker's recommended points and use a two-post or mobile hoist. The lifting of heavy components of the straightening equipment is also a hazard for the panel beater. Injuries from lifting, mainly to the back, top the list of industrial accidents and illnesses. Lifting should not be done with a bent back. The back should be held straight and the cantilever action of the legs used for the lift. Heavy items may also be dropped, and industrial footwear is essential. Shoes or boots rated at 120 joules may suffice, but those of 200 joules are better. Full details of all personal protective equipment can be found in the program Look After Yourself. Remember, the law holds the operative responsible for health and safety as well as the manager. Damage assessment is common to both the estimator and to the panel beater, who will straighten and rebuild the vehicle. There are four main factors to consider: the direction and nature of the primary impact in all three planes, secondary damage from reaction, components, occupants and load, additional damage from other sources after the initial impact, problems arising from poor pre-accident condition. In this program, the demonstrator is seen taking notes as if compiling an estimate. A panel beater is more likely to check an existing estimate for the content and scope of the job. Each inspection is important. The estimator is initially interested in obtaining and controlling the job, whereas the panel beater is getting to know what needs doing and how it may be done. Checking the job before starting is particularly important when estimating is a little less than thorough. Assessment commences with a walk-round to gain an overall impression of the scope of the job. The shapes of all symmetrical panels are checked and their relationship with those adjacent to them. For example, the tailgate, the roof panel above it, and the sill panel below should form a symmetrical pattern when viewed from directly behind the car. Close examination starts at the impacted area. There is obviously underbonnet damage, and, sure enough, the crumple zone in the chassis leg has done its job. The front right wing and the nearby door, particularly the gaps between them, are checked. No surprises here. The gap has closed up. Moving along to the B post, the roof panel is checked for creases that would indicate compression of the passenger cell, or for other damage. Light reflection and touch are used to good effect. Dropping down to the B post, door misalignment is obvious, and is also shown by the contour lines. The door is open to check the door shut. As might be expected, the door fouls the front wing. Continuing now to the rear, our demonstrator squats down to look along the body's side, again using light reflection to check the panels. The contour lines are particularly useful. Passing across the undamaged rear, the damaged left rear door is now examined. The door trim is missing and the wing guard loosened. Taking no chances, the demonstrator checks thoroughly. But is this part of the accident, or did it already exist? It could be secondary damage from striking an obstacle or another vehicle. By the time of repair, of course, that decision should have been made. Moving now to the damaged left front wing, gaps and general shape are checked. The absence of the flasher repeater draws attention to that area. Returning to the front, the bonnet is lowered and a final check made of the major damage area. A thorough underbody inspection is a vital part of damage assessment. The ease of access of a two-post hoist is particularly useful. In this case, the damaged structural members can be seen from a different angle, and parts hidden from above are in view. Wheels are turned to check for buckles. All visible components and pipework can be examined, and the underbody checked for signs of impact, deformation, and corrosion. The condition of the sills will be of interest, for it's here that the clamps will be attached that help anchor the car against the reaction of pulling. Anti-corrosion coatings are also important. Any damage, even if not related to the accident, should be reported. After lowering the hoist, the interior can be checked. Apart from primary damage, the interior could be damaged or soiled by the impact from occupants or load. On vehicles fitted with the Procon 10 system, there may be damage to the dash assembly, and of course, the system itself will need renewal and resetting. It's sometimes difficult to discover the full extent of the damage inflicted to a vehicle, but every reasonable effort should be made to do so, particularly where the repair cost is close to write-off value. For the panel beater expected to rebuild the vehicle to factory standards, an overall understanding of what is damaged and in what way is the first step in that process. One other check that can help in diagnosis is the measurement of wheel alignment and steering geometry. Allied to this is the need to check that cars which have stabilized steering are equipped with the correct wheels. Incorrect offset can alter or cancel this superb safety feature. Measuring wheel alignment can confirm an opinion based on visual signs and experience. But of course, it does more than that. It provides firm facts, precise figures which pinpoint any problem. The same is true of body damage assessment. Visual signs and experience can be used effectively, especially where the damage is dealt with frequently. But only by actually checking positions or dimensions will the truth or distortion of the bodywork be confirmed by precise measurements. This car is, to the untrained eye, perfectly normal, but the professional notices that the bonnet and the doors do not line up too well, and a newly fitted anti-roll bar is misplaced to one side. The displacement has been cleaned to make it easily seen. It's the perfect subject for a measuring system. The Celette Metro 2000 system is used here. It is based on a simple ladder frame which is laid on a perfectly level base, in this case, a standard Celette mobile bench. Suspended over the bench on 4 jacking sill clamps is the vehicle to be measured. The accuracy of the readings depends on how well the frame and vehicle are aligned to each other. This is easily done. The body is jacked or lowered until the least damaged section of the body is at the correct height. The frame is moved laterally to line up with the vehicle centerline, and the lengthwise measuring tape is simply moved to its datum position. The first step is to find the data sheet and attach it to the car. Data sheets follow the same basic format, and they always show location of the measurement points, Table 1 giving details of the measuring adapters and the correct measurements for complete vehicles, Table 2, which has identical information for body shells without mechanical units, and this part has width readings, with length figures for each position just below. Special items of information are also shown, together with the setup for the measurement of the front suspension strut mountings. The first information needed is the position and settings for the sill clamps. These are measured off on the sills and marked with masking tape. Sill clamp carriers are mounted to the bench on eccentric shafts. Inserted into these are jacking sill clamps, raised or lowered by large triangular nuts on top, and locked by an identical nut below. Scales on the sides of the carriers are used to position the jacking sill clamps laterally. The height of each clamp is also preset by scales recessed into the pillars of the sill clamps, but the triangular nuts are not tightened at this time. A mobile hoist is used to raise the car. And the bench moved into place. Sill clamp positions are checked and adjusted if necessary, both laterally and to bring them centrally under the tape marks. Notice how the demonstrator uses his leg to take the main weight of the carrier when he moves it. The sill clamp bar is now rotated upwards to lock the carrier to the bench. The car is lowered to just above the sill clamps. Any final adjustment is made. And then it is lowered fully into place. The hoist is now removed. And the measuring frame entered with the arrow to the front. Sill clamps are closed up but not tightened. The lower triangular pillar nuts are also left loose. With the fittings unit close by and the data sheet handy, the half bridges which carry the made-up adapters are installed on their trolleys. The red mark is to the outside. The width readings on the datasheet underpan view determine where the different lengths are installed. They are retained with an Allen screw. Here we see the makeup and installation of the carrier and adapter for point 8, one of the main datum positions. Carrier 1, a 50mm extension, it just clips in, and adapter L, which also clips in. The carrier assembly is fitted to the half bridge and retained with a thumb screw. Then the whole assembly is moved about until the adapter can fully enter its location, when the carrier locking ring is lightly tightened. It's most important that adapters are properly fitted into or onto their locations. At the other chosen main datum point, number 5, the carrier assembly is made up in a similar way, except that the adapter fits over a front suspension mounting bolt. With the carrier assemblies fitted at the 4 chosen datum points, the height is set with the jacking sill clamps. The lower triangular nuts are still loose. Alignment of the car centerline to the measuring system is done by sliding the frame laterally until the 4 half bridges give correct readings. Now that the measuring system and the body are aligned to each other, the sill clamps and the lower triangular sill clamp nuts are tightened. Longitudinal alignment is simply set by moving the tape to the datum position. The frame is now clamped to the bench with eccentric washers, and all settings are rechecked. With basic installation and calibration completed, additional adapter assemblies are fitted to take measurements at other points. Readings at the front show that the car has been badly repaired on the right. The height is 4mm low, and it's no less than 27mm to the left. This explains the displacement of the anti-roll bar. This equipment can be used to measure the top suspension mounting with the running gear in place. It can show discrepancy, as here, or provide accurate measurements. The Metro 2000 measuring system has been seen here carrying out its role as a diagnostic tool, but it can also be used as a universal repair system. There are times when the power of a hydraulic pulling system is needed to repair some localized minor distortion. This car has suffered an impact at the rear which has pushed the bumper mounting slightly inwards. Damage is clearly confined to the bumper mounting point, and it needs a strong but short pull to put matters right. The Celette System 5000 is a simple floor frame which provides anchorage for both the vehicle and the hydraulic tower. A mobile hoist is ideal for lifting the car. Sill clamp supports are positioned and locked with wedges. The sill clamps are installed with the adjustable pair at one end of the sills. The car is lowered to the top of the clamps for final positioning and height adjustment. Then it is lowered completely into the clamps. Both the sill clamps and the supports are tightened. And the hoist removed. A suitable pulling plate is bolted into place. And the hydraulic tower positioned. The safety anchor is clamped into place. This prevents imbalance of the tower in the event of panels breaking away. Rear anchors and chains are placed ready. Adjusting the height of the pull is done quite simply by moving the pulley up or down the tower. Then the anchor chains are put into the hooks on the pulley and their self-locking blocks are tightened up. The pulling chain is fed through the pulling plate and locked with a double hook. A safety strop is attached. An air supply is connected and the pulling carried out. The Celette bracket system has been the standard Volkswagen repair equipment for many years. The MZ system has also been approved and is used in this sequence to repair the Jetta assessed earlier. A two-post hoist is being used for loading. The power unit and suspension have already been removed. All datum points must be checked for damage and cleared of any obstructing matter before starting the repair. The sills must also be checked for condition. This can be done quickly and easily on the hoist. Preparation of the bench commences with assembling the modular cross members into place. The first two lay along the beams, following the line of the side members and allowing better access to the engine compartment. The others are true cross members. The four chosen datum point towers and tops are bolted loosely into place. Then the bench is positioned under the car. The car is lowered until it's just above the datum point towers. Aligned exactly. Lowered completely, and the towers tightened. Now the remaining towers and tops are fitted. Our demonstrator followed a number of straightforward but important rules that are essential for successful use of this equipment. Work in a sequence, from undamaged to damaged. Use the data sheet. Select 4 datum points on the undamaged part of the car, far enough apart, within reason, to give accurate positioning. Hang the tops and towers from the car whenever possible. It makes work easier. And finally, no strain on any fitting. Working to these guidelines will ensure that the undamaged area of the underbody is clearly defined. Now the body must be firmly anchored against reaction from the pulling. Sill clamp supports and sill clamps must be used, and these are attached to the bench. They are then adjusted up to and against the sill. The support is adjusted for height, and then the clamp is tightened. With the front panels removed for ease of access, the front towers and tops are fitted, enabling the extent and severity of the impact damage to be accurately assessed. They will also act as gauges during the pulling. This and detailed knowledge of body distortion elsewhere is critical in deciding how best to arrange the pulling. In this instance, the side member has also twisted, and the A post has moved back, which will call for a number of pulls. The first pull will be applied to the side member, and so a pulling plate is fitted. The hydraulic puller is clamped to the bench. A wedge holds it firmly in position. Having decided the position from which the first pull will be made, the swiveling base of the Cayman unit is swung into place and the pivoting arm moved. Chain position is also adjustable and the most suitable point chosen. A safety strop must always be used and is now clipped on. Using the compressed air controller, pressure is applied. A number of important safety rules apply to this work. No other person should be working on the vehicle at the same time. Keep observers well back. A careful but not close watch must be kept whenever pressure is applied. Spread the pulling load or use multiple pulls to prevent high-strength steels from tearing. Check progress constantly. Never leave a pull unattended when it is under pressure. Always use safety strops on all pulling attachments. The first pull is made. The damaged crumple zone can be seen unfolding. After assessing the effect, the chain is repositioned and pulling continues. Stress is relieved by beating when the bodywork is under tension. The effect of the blows is to restore molecular order within the metal. If the material is high-strength steel, the folds must be eased out more slowly. Stress-relieving beating is also needed more frequently, followed by easing of the tension before recommencing pulling. Whatever the material, tension must be released before the position is checked or anchored with the top. A clamp is now used to pull on the upper part of the side member. Pressure is applied to continue, and we see why safety strops are so important. Again, the effect is checked, both with the tops and by checking the other affected parts of the body. One more pull is needed to apply pressure more directly to the upper part of the inner wing panel. This will finish the reshaping of the main body and bring the side member back to its position. The outer wing is removed and a clamp fitted. The inner wing panel is pulled, and more beating applied to relieve stress. Checking shows that shape has been restored and the top fits perfectly. Replacement of the body components that have been weakened or too distorted to reuse can begin. Using the procedures and cutting lines in the manual, the inner wing panel and the side member are cut back to sound material. Using part panels or cutting parts to fit, the body can be rebuilt. The cut side member is ready for welding. As in setting up the undamaged part of the vehicle, it's imperative that components fit the tops perfectly without any stress. Building continues with the inner wing panel and the filler plates, front lock plate and panel, and is now complete with the bonnet. During rebuilding, these essential guidelines are followed. Support the vehicle firmly and locate it accurately. Locate replacement parts firmly and accurately. Use the manual and rebuild to factory requirements. Careful compliance with these guidelines will result in these benefits. The correct mounting of parts will provide an automatic check of accuracy in straightening and rebuilding. Careful work will prevent built-in stress and maintain accuracy. High quality of alignment and location is certain. But at all stages, checking and rechecking is the secret of a successful and, above all, a safe repair, which restores all the features of the new car. All the principles and practices dealt with in the previous sections have centered around quite simple and straightforward damage. What is the procedure if the job is less common? Apart from some practical differences in the angle or the number of pulls, the same basic principles apply. Here are some suggestions to help with the various types of damage usually found and their straightening procedures. When one end of a vehicle is out of alignment laterally with the main body, this is called side sway. With the body held firmly, the distorted end is pulled over until it again aligns. A more difficult form of this condition is caused by the side of the passenger cell striking a pole or tree. This is called a banana. The bend in the sill in these cases calls for a remedy that is a little more involved than the side sway. The end is pulled over while the body is held firmly, but the arrangement is slightly different. The end of the body is also tensioned longitudinally and pressure applied to the bent sill. If the car is struck by another braking hard at the time of impact, a sag almost inevitably occurs. In this state, the front will be bent upwards and may also have other damage. The sag is dealt with by holding the main undamaged part of the body and pulling the front downwards. If the damage is to both sides, a double pull is indicated. A collapse is the opposite of the sag. The front must be lifted while the body is restrained. The defect referred to as a diamond is where one side of the body is a little behind the other. This type of damage is more usually found on chassis-based vehicles or those which do not have effective crumple zones. It's generally agreed that the best method is to hold the forward side and draw the other into alignment. A twisted body is where a corner is high. This can be put right by holding the undamaged end, supporting the other correct corner, and pulling the high corner into place. Finally, the one type of damage that may easily be incorporated into many of the others is the mash or crumple. A direct frontal impact will result in compression of the bodywork. The same may happen at the rear, of course, from a direct impact by another vehicle. A mash is drawn out by a direct pull or pulls with the undamaged part of the body firmly clamped. This program has been produced to bring up to date the in-dealer training modules on the subject of body misalignment and straightening. There are no very great changes in the principles or practices as far as the vehicles are concerned, but there have been changes to the equipment available. Changes which encourage any size of body shop to invest in that best suited to the business. That is just as well because the vehicle makers now impose stringent requirements through the body warranties. But even more significant is the adoption in the United Kingdom and throughout Europe of quality assurance. This means that the repaired vehicle must not only look good, it must be functionally perfect in every respect. At the same time, insurance companies seeking to reduce the ever-increasing costs of providing cover for the motorist are not keen to pay more for body repairs. Estimates, the start point for virtually all body repairs, will only be viable if they can be produced quickly and accurately. That means the right equipment used properly. Rebuilding the bodywork can only meet all requirements if it's carried out to the vehicle maker's specifications, using genuine parts, assembled on accurate jigs, and welded correctly into a perfectly aligned structure. Only by adhering to the highest standards of work practice can it be certain that the vehicle occupants will be protected as well after the accident as they were before it.